afternoon, boys and girls, my friends that are doing school at home this year. Today we're going to do some STEM water experiments. So you're going to need, before we get started, 5 clear cups or jars, a penny, and maybe some other coins, some paper clips, the little ones, dish soap, food coloring, and blue, yellow, and red, white paper towels, a pipette or a medicine dropper, and if you don't have one, you can certainly get one at the library. So for our first experiment, we're going to see if we can get a paper clip to float on top of water. I put my paper clip in the water normally. What does it do? It sank to the bottom. Let's see if we can make it float on top. What do you think? Is it gonna work? I don't know. Let's see what we can do. Very carefully, I'm gonna set it on top. I got it to float. Okay, so did you get yours to float? It's kind of tricky. What do you think is making it float? The scientific term for this is surface tension. Surface tension is one of the most important properties of water. It's the reason water collects in drops, and it's also the reason plant stems can drink water. We're going to see if we can break up that surface tension, and one thing that can break surface tension is dish soap. So I'm going to pour a little bit of dish soap in there to see if we can make the paper clip float, see if it breaks that surface tension up. It fell because the surface tension broke. So the next thing we're going to do is see how many drops of water stick together on a penny. So you need to find a penny. We are going to take our little pipette and we're going to take some water and we're going to start counting drops of water on there. And before you do this, you're going to do this 3 different times with 3 different pennies. So what you'll want to do is make a chart that has columns and rows that look something like this. Let's see how many drops of water we can get on our first penny. Here we go. 1. We're gonna see how many drops of water we can put on there without it spilling over. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, I got up to 14 drops when I put the 15th one on the water spilled. So we're going to put number 14 for the first one. So let's do another penny. We're going to move this out of the way. And see how many drops we get on this penny. You think it'll be the same? Do you think it's going to be different? What do you guys think? All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that one only got up to 10 before it spilled. So I'm going to write 10 under my second try. 1 more penny. Why do you think we're doing more than 1 penny? We are doing more than 1 penny because we want to get the average number of drops that we can put on a penny before the water spills. All right, 1 more. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that bubble. 11, 12, 13, 14, 15, 16. Whoa, look at that one. 17, 18, 19. Oh my goodness. This one has a lot. 20, 21, 22, 23, 24. That one's going crazy. 25, 26, 27, 28, 29. Look at that bubble, 28. Whoa, that one got up to 28 drops. That was pretty cool. How many drops did you get on each penny? Here comes the tricky part. If you need help with this part, you can have your parents help you with the math. What you're going to do next to find the average of how many drops fit on your pennies is to add these three numbers up. 12. 1, 2, 3, 4, 5. The number of drops on all three pennies was 52. You have to add those three numbers up. Then you're going to divide by 3 because that's how many pennies we had. 3 will go into 5 one time. Then you subtract 22. 3 times 7 is 21. So we had 1 left over. So our average number of drops that fit on our penny is 17. I thought that last one is pretty cool. I didn't expect to get 28 drops on one penny. I thought, oh, maybe 10, 11, 12, 13, but definitely not 28. That I did not get. My prediction was not correct. Okay, I'm going to try one more thing with our pennies. I'm going to put some drops of water on that one again. This time, we're going to see if I put a drop of soap on it, is it going to break the surface tension? Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to stop there. Okay, so see what happens when I put a drop of soap on there. Is it going to stay? Is it going to break the surface tension? What happens? And you can do this too. It's not what's supposed to happen. Okay, let's try again. Let's see what happens when we put some soap on there. Oh, there we go. So the soap broke the surface tension of the penny, of the water on the penny. One more surface tension experiment. This one, you have to fill your cup with water as far as you can. We'll want to fill it all the way almost up to the top. Okay, now I'm going to see how many pennies I can put in my cup before it overflows. Okay, are you ready? I'm going to put in 4 at a time because this might take a while. Let's do 5. 5 pennies at a time. There's 5. 10. 148. 149. 150. 151. 152. 153, 154, 155, 56, 157, 158. Uh-oh. Oh, it's getting close. Look at that. It's over the top. 159. What's stopping it from spilling? 160, 161. This is crazy. 180. 181. Look at that. 182. 183. Oh, there it goes. Let's see what happens if I put a drop in. Let's see if it really spills. There. So when we put the soap in, then the water really started spilling. Okay, so for our next water experiment that we're going to do, we're going to talk about how water absorbs. And we have some really cool books that have other water experiments in them that you can use. The absorb water one I'm going to use is from this book called Make This. And then we also have this book called Science with Water that you could check out at the library. We have this book called Liquid Planet that has some cool experiments. So, and we have lots more books. I only brought out 3. So, we're going to look at the experiment in this book, and it's called Walking Water. So, you probably know that when you wear sneakers, your feet get wet. And so your shoes and your socks are absorbing water. But there's also other materials that water doesn't soak into, and these repel water. So understanding how water moves through absorbent materials is important. If you know how water moves, then you can better control its movement. So we are going to do this experiment. I thought it was really cool. It's called walking on water. What you're going to need for this experiment is 5 plastic clear cups, red, yellow, and blue food coloring, some paper towels, and water. That's it. So the first thing you're going to do is fill 3 cups of water. Get our books out of the way. We don't want those to get wet. Line your cups up in a row. Space them evenly apart. You're going to fill the first one about 3/4 cup full, about that full. We're going to fill the middle one the same amount. And we're going to fill the last one the same amount. Why do you think I didn't put water in here? That's part of our experiment. We're going to see if water is absorbed through paper towels. So we're going to add some red food coloring to this cup. 3 or 4 drops probably. Then you're going to add yellow to the middle one. Oops. About the same. Then you're going to add blue to the last one. I'm really excited for this experiment. I've never seen it done before. Okay, so we've got some blue in there. You're going to take some paper towels, 1 paper towel square, and you're going to roll it into a long tube. So you roll it into a tube. You'll kind of want to twist it a little bit so it stays. We're going to place one end in the red cup and one end in the empty cup next to it. Looking at our cups, what's your prediction? What do you think will happen with the water and the paper towels? Now this experiment's going to take a little bit, so we'll come back in a little while and check on it to see what happened. All right. Boys and girls, we let our cups set for a couple of hours, and this is what happened. I think it's pretty cool. This is probably one of my favorite experiments. Why do you think the water traveled from one cup to the other? I want you to think about that for a second. Okay, so the paper towels are absorbent, so they're going to soak up the water, and then the water traveled to the other cup, and the blue and the yellow mix to make green, and then yellow and red mix to make orange. So we call the process where the water moves up the paper towels, it's called capillary action, kind of like your capillaries in your body. So moving the water up the paper towel, something solid, into the other cup is called capillary action. Do you think it would work with like old socks or fabric? You should try it with other materials, even other liquid like oil, vinegar, and see what happens. I'm curious to know. What do you think would happen if you use tinfoil? Is that going to work? Is tinfoil absorbent? Wax paper, other materials. Okay, so the paper towel is absorbent, and it's called capillary action. If you do this experiment and you do other variables, let us know. I'd love to hear what you found out. Okay, boys and girls, thank you for joining us today. I hope you had some fun with our water experiments, and you can sure Google STEM water experiments, finds all kinds of experiments to do with water. And like I said, we have lots of books you can come and check out. Please let us know how your experiment went. You can let us know on Facebook or on YouTube. You can comment on our video. We'll see you next time.